In a moment, I'm going to be introducing you to our second panel when we're going to be talking about the appliance of science to achieving better food systems. And we're also going to have our Slido questions. We want to know what you think about a couple of key points that we'll be discussing with our panel. So we've our third poll question for you now. And that is, which area of research and innovation in agri-food requires the most attention to address key food system challenges by 2030? So we'll be really interested in your response on this. Is it food authenticity and safety systems? Is it fisheries and aquaculture? Is it nature-based solutions and circular economy approaches? Is it healthy and personalised nutrition? Is it genetic improvements? So please let us know what you think on all of those, and we'll be feeding the results of that poll into our discussion with our panel presently. I also want to tell you about the fourth dialogue of this series. That's going to be taking place on the 17th of May, the 17th, not next Monday, so pop that date into your diaries. Our chair on the 17th will be Rory de Bourke. He's Director General of Irish Aid at the Department of Foreign Affairs. And the theme that afternoon, because we've had very much a domestic focus for today's dialogue and the previous two, but the theme that afternoon is how we align domestic and foreign policy to achieve the goal of more sustainable food systems. And once again, we're going to have some great speakers for you, including keynote speakers, Dr. Susanna Moorhead, who's chair of the Development Assistance Committee at the OECD, and Dr. Jamie Morrison, Director at the Food and Agriculture Organisation. And the public consultation on the National Agri-Food Strategy remains open until June. So just go to gov.ie/consultations. And now, by the magic of science, we have our new panel in place for you. So please let me introduce them. And Dr. Maeve Henshin is Principal Research Officer with Teagasc. She's here in a personal capacity today. She's on the board of the Food Safety Authority and on the executive of BioOrbic, Ireland's Bioeconomy Research Centre. She's also involved with the SCAR Food Systems Working Group. Her interests are innovation in the circular bioeconomy and sustainable food systems. Joining us remotely, Dr. Nora Caldey is founder and CEO of Neuritas, which uses technology to get the most from nature. Their aim is new discoveries that could benefit the lives and health of billions of people globally. Alvan Hunt is the co-founder and chief executive of Hexafly and Irish Agritech. His mission to revolutionise the way we feed this world by breeding insects on an industrial scale and doing that sustainably as well. And Professor O'Connor is the director of BioOrbic, the Science Foundation Ireland Bioeconomy Research Centre at UCD. He's also set up two companies, Bioplastec and Nova Mentis. So a huge amount of brain power on this panel, and you're all very welcome. And Maeve, maybe you'd kick us off with this question of the appliance of science and this brave new world of food that's coming to us. And, you know, we know the strategy, we know what we're all trying to achieve, and we want it to be circular, we want it to be sustainable, we want it to be affordable, accessible, ethical. How close are we to doing all that, and what do we need to be focusing on, in your view?
Well, I suppose, yeah, there's a lot we're asking from the system there. And I suppose I don't really want to throw cold water on things from the outset, but I suppose the important thing to recognise that absolutely science and technology has brought us a huge way. We're producing a lot more milk, say, with less inputs and less environmental impact than in the past. We have fantastic developments with new technologies around adding value to co-processing and waste streams. But I think we have to recognise that science and technology can only bring us some of the way. And therefore, I think that then speaks to the argument for the food systems approach. And I suppose what the point that I would make then around relating to that is we have to understand we're not just simply about trying to develop new technologies and new crops. We're trying to develop new systems. And that ultimately means change. We have to understand the different relationships and interconnections that are there. We have to understand that we require changes in power. We require changes in mindsets. And then I would argue that we need a much more stronger emphasis on the social sciences in terms of understanding all of that change and facilitating the introduction of new science and technology solutions to the food system then.
Yeah, there is an awful lot of education and explaining that's going to have to go on to bring, stakeholders right across the society with us, isn't there? I mean, that's one thing that's been coming very clear. Nora Caldey, talk to us, though, about the brave new world of food production and looking at food or food elements in a different way and using new technology, because we've been hearing so much about, people's poor diets, how food is making us sick, how people can't afford food. So talk to us about the appliance of science and how that can help, and your work in Eurotas.
Yeah, thank you. So it's incredible. Yeah, food has really become a problem, okay? And it shouldn't be, because food is really the solution to all this, but it hasn't been used the right way. And the realization that we know very little about food and how food interacts with the human body was a big thing for myself as an academic initially, realizing that, if you take a plant, you're talking about trillions of different molecules within that plant. To understand what molecule does what and how it interacts with the human body is just a huge mathematical problem that currently humans have not really understood. So we're not really close. A few years back, about 10 years ago, we weren't really close to understanding the complexity of food and how we extract health benefits from it. And this is why introducing new technologies to old areas like food and food production is very important, because we live in a data-rich world. And the question is, how do you use that data and how do you integrate new technologies to decipher that data better and to understand it better? So if I give you a concrete example, if you take any source material, let's say a plant, and you eat it, you lose a lot of the health benefits within that plant. So even if you eat it fully, so as a whole foods, you lose a lot of benefits, a lot of health benefits that are in the plant. But when you digest it, you lose a lot of it. You get the nutritional part, but a lot of the very specific health benefits you lose. Also, when that whole foods is processed to create a finished product, a lot of those health benefits are also destroyed throughout the production. So what we did was try and understand, well, how can we identify those incredible health benefits are hidden for hundreds of millions of years in all sources, in all plants around us, in all marine sources, etc. And how do we make them available to humans so that we can use food to its full power? We can use plant to its full power, because currently, there's a global, clear augmentation in the number of people. There's need for more food, but actually we're not using food to its full potential, even what we have currently. So the fundamental understanding of what's in source materials, what are the health benefits there that we're losing as humans, how can we make them more available, how can we take those ingredients that you then create and put them into different food sources, into different food products to improve human health, has been really the mission we've been on for a while. So like I said, there was no way to identify these incredible benefits within food without actually without doing it through computer science. And just another example, a more concrete example, let's say you take fava bean, okay? What we discovered recently in fava bean is a network of different molecules, short proteins called peptides. So they're short proteins within fava bean that when you eat the fava bean itself, you don't get their power, but the power of these peptides improve muscle health. Now, muscle, people don't think about it much, but muscle is the major organ within the human body. It is the organ that we use to move. It is our metabolic heart, our energy heart, it's the first aging part as we sag. That's really to do with muscle aging, and the performance of it is very important. And it really is key to our health and well-being for a long period of time. So what's interesting is that there's currently no real solutions to improve the fundamental health of muscle. And what we did over the past few years is try and identify solutions for muscle in nature. And we found a network, like I said, of peptides, which are short proteins in fava bean, that really tremendously, significantly shift the muscle from an aging muscle to a healthier, younger muscle. And I won't go into more science than that, but basically those benefits would have been lost if you did eat the fava bean on its own. And obviously the fava bean went through a food processing, the same thing would have happened. So in a nutshell, food should be the solution. We're not using it the right way. and the fundamental understanding of what's in food, what's in our plants around us, plants and other sources, is really important to be able to structure and create better products, healthier products with the same taste using new technologies.
That's absolutely fascinating stuff, and I wouldn't even have to shell the fava beans to get all the benefits. I could just take you a supplement. Besides which, the idea of broad beans being the new Botox, I'm still kind of getting my head around that. Talk to me about the business of trying to, I mean, farming insects, we've all, we've all heard somewhere, in the future we'll all be eating insects because they're so nutritious. Most of us don't want to. You decided to go into it as a line of business, but I mean, it's such a fantastic concept. We know it is the future, but what's your practical experience being of trying to get a fly factory off the ground?
Yeah, well, it's a new industry. Doing something that's, I suppose, new and innovative is always going to be difficult and challenging.
Did people tell you were nuts?
A few people did, yeah. I suppose when we started, it was really kind of early stage. The industry was only really getting started globally at that stage. So, like, there's been a lot of there's a lot in the media about insect farming now, and it's received huge amount of investment since. But when we started, it was very much at the conceptual stage. Even, there had been a lot of scientific research, but as a practical solution, it was still quite early.
And come here to me, Alvan, why did you want to go into flies instead of beef, for instance?
So we were looking at, I suppose, the future population growth is going to be an extra 2.2 billion by 2050. The demand for protein, not just for the human population, but actually on a more practical level for animals, the need for protein to be used in animal feed. And we saw that there was industrial, the agri sector and the industrial sector were predicting that there would be shortages and there would be a gap there in that protein production. So we looked at insects. Insects are really, really high in protein. For example, like the insect we use, black soldier fly, it's got 60% protein. The insects had a 2.5 week life cycle, quick turnaround. They were able to take in raw material food waste that we produce, that's produced in society, and instead of that being discarded, they can actually turn that.
Did they have any favourites?
They do, yeah. They certain foods or waste streams they prefer. Stuff of vegetable or vegetal origin is quite good. Distillery byproduct as well, certain grains and things like that.
There's a surprise.
So
what was the experience? I mean, was there local support? Was there official support? What was your experience?
So it was challenging. So there was two elements to it. There was getting the investment in the first place. That we were able to do over time. Then there was obviously the legislation side of things as well. So actually, when we started the business, there was no legislative framework to grow or farm insects at all. So we were kind of in this really kind of strange grey area.
Where it was kind of, did you even know it was legal?
Well, it was in America, and we thought, well, what's going on in Europe? Then we realised, look, there was big moves at a European level to bring this, to bring this into law for aquaculture and pet food. So we were following those developments. But when we were in Ireland and we were looking for, well, what license do you even need for this? That type of thing. So that was challenging because there was no framework in place when we started to go. But then the European Commission passed a lot of the legislation, and then we were able to work with something. But it was challenging. It took a long time to get the approvals we needed. But I suppose there was learnings there on both sides. There was no use case. There was no.
It was a learning on the official side as well.
It was learning on both sides for sure.
And there's going to have to be a lot more of that in the years ahead, isn't that right? In all kinds of areas.
I think so. I think like technology moves at a very quick, very fast pace. Innovation is moving fast. The solutions we need we need them now. So legislation and regulation there needs to be a matching there of how that can fit in together from a timeline perspective. Obviously, there's the commercials of trying to get things going versus balancing the health and safety and the regulation side of things. But it has worked out. We're approved and we're growing as a business, and globally the business is insect farming is expanding at a rapid rate. So it's a good solution, I think.
Okay, it's absolutely fascinating stuff, and fair play to your innovation. And Kevin, just talking actually before I come to you, the question I'm going to give to you is to look for a reaction to our Slido poll, which was which area of research and innovation in agri-food requires the most attention to address key food system challenges by 2030. Was it food authenticity, traceability and safety systems? 13% thought so. Fisheries and aquaculture, only 8%. Healthy and personalised nutrition, 16%. Genetic improvements, only 5%. But nature-based solutions and circular economy approaches were a whopping 58%. What is a circular economy in food production? And how does research and development need to play into that? Can you hear me, yes. Kevin?
I can hear you, yeah. Sorry. Just went blippy there for I'm at home and my internet connection isn't great. It's a big question. What is a circular economy and how can it feed into our food system?
Because it is one of those big terms that's thrown around. So I thought it would be useful to break it down.
Yeah, absolutely. So I suppose right now we live in a linear economy. We take something out of the ground, like fossil-based resources, oil, gas, we convert that into something. That something can be fertilizer, actually. And that fertilizer goes into a field. But it's a make, break, throw away society. That's what we have. That is a linear economy. The circular economy is trying to take our resources and say, okay, let's keep them in the material cycle. Let's keep them in the economy for as long as possible. Let's try to design them so that they can be reused. Let's make them so that they can create as much value and as many jobs as possible. Let's create them so that they don't generate a huge amount of waste. Let's create them so that we are ultimately reducing the amount of energy that is used to make them or to reuse them. So it's a holistic view of how we use materials and the impact the use and creation of those materials is having. So a circular economy should ultimately reduce our footprint. It should reduce our impact on the environment while still creating jobs, creating wealth, and ultimately contributing to sustainability.
And it is the only way we're going to be able to feed more people on this planet without burning it up, isn't it?
Absolutely. You know, we absolutely have to think circular in our thinking. And in food production, someone mentioned it earlier, I think someone mentioned earlier, but 30% of the food that we produce goes to waste. It never gets to be consumed. It's never consumed by a human being. So we have a massive, I think Nora said it, you know, that we're not getting the best out of our food. Well, we're not only not getting maybe the interesting molecules that Nora's looking for, but we're also not getting efficiency in our food systems. And actually, a lot of that isn't down to agriculture. Agriculture is actually quite efficient at production. It's the supply chains after that. Yeah, and it's our 2-for-1 offer, the 3-for-1 offer. Have I stopped?
No, we're still hearing you. Go on, Kevin. Yeah. Oh, no, hold that thought then, and we'll come back to you.
I'm still there. Sorry.
No, that was a really interesting point you were making, if you still hear me, about the inefficiency in the food systems, if you like, being beyond the farm gate.
Yeah, so...
no, we'll see if we can improve that. Just hold there the line, Kevin. We'll see if we can sort that out a little bit. Before I'll come back to you on that, Maeve. But before I do, I want to give you another Slido question, which is: research and innovation can make the biggest contribution to achieving a sustainable food system. Do you strongly agree, neither agree nor disagree, or disagree, or strongly disagree? And this is how much this question of how much uncomfortable change do we have to make in our own lives and the way we do business now, Maeve, isn't it? Compared with how much will, you know, somebody like Nora come along with a way of using artificial intelligence to get the most out of a fava bean and new products.
Sorry, Anya, what's the
just
question?
On the balance there.
The balance of the change in the system, is it?
Yeah.
Yeah, well, I think there's huge potential for change all along the system. And we did some work recently looking at the opportunities to add value to co-processing streams in the meat industry. And we found there's about at least 250 potential opportunities there that we can look at valorising into the future. But maybe I can come back a little bit as well and speak to the point about the role of livestock production in the food system. And Teagasc is actually organising an independent dialogue around that in parallel with the national dialogues, I suppose, to try and bring a bit of balance to the argument around it.
Because it was interesting, our Slido posters weren't that impressed by genetics as being, you know, the answer, and a lot of farmers are saying we'll be able to breed, you know, a herd that will produce much less biomethane, and genetics is crucially important to that.
Yeah, absolutely. Well, genetics is part of it, and then feeding strategies are all part of it as well. But I think the point I was trying to make is that we have to look at what are cattle actually doing. And, you know, we have the point here that insects are converting non-human edible food into feed, or food for humans. Cattle are actually doing the same thing. So they're converting non-human edible food, grass,